Hi and welcome to Soft Hints. This is another video about the book Think Python, and this video is about chapter 4. You can see some of the important topics here, like encapsulation, generalization, interface design, refactoring, docstrings, and so on. So we can start first with introducing a turtle model. You can find the official documentation of this model here, and it's about graphics. Normally it's built in Python and you can use it with import turtle. And also you can see some really interesting examples on this link here and some methods. I will add it in the description below. So let's continue. In general, you can find the model version by using this statement here. You can import the model and then you can get the information with pandas, for example, dot and version. As you can see right now, we can get the information for this model, or you can use pip freeze and then get again the information for a given model. In this case, we're going to check do we have the model by using a simple import, and if the import is okay, this means that you have the model and you can use it. So here I want to say something which is from the author of the book, that turtle model, which is with lowercase, provide a function turtle. You can see it here, which is with uppercase. This function is going to create an object, and this object we are going to assign to variable bob and later use it. So let's demonstrate what turtle is doing. As you can see, we have a canvas and we can draw something on this canvas. By the way, I will use import OS exit in order to restart the kernel, because otherwise the program would have some errors due to the Jupyter Notebook. And now let's draw something simple like right angle, which can be done by using these lines here, which means write or draw something forward, then do a angle, and then again write it forward. So as you can see, the program is drawing something, then it's turning, and again it's drawing. You can see the pen here, or the pointer. So let's close this window and continue. Now let's say something important in programming, that you have a method and you have a function, which can be considered as similar things, but they have slight differences, and you can read for the differences here, which is taken from the web. The most important is that a function is a statement which can be called by a name. The method is similar, but this method is associated with an object. So this is a difference, and how you can work with data for function and methods. So you can use this for yourself and for further references when you're dealing with functions and methods in Python. And now let's say that you need to draw a square. How you can draw a square, you can think for a while, and maybe you are seeing an example solution on the screen below here. And if you do this is not wrong. This is one of the ways to do it, and let's check the result. As you can see right now, we have a square which is drawn by this program with several repetitions. You can see that we have drawing a line, then turn, again the same, and you have 4 repetitions here. Can you think of another way to do this exactly the same, but in a shorter form? And maybe you can see here at the bottom that we have a for statement is called a loop, because the flow of execution runs through the body and then return back to the top. And maybe yes, you can think for loop and do it. For example, we can print several times hello by using a for loop in this way. And you can see the output. Of course, we can reuse this for the same program and draw a rectangle. This is the program. You have all the repetitions from this program put in for loop, and we're going to run them 4 times because we're saying that we want to get a range from 0 to 4. And let's check the output. As you can see right now we have a square, and here it's important, can you notice a difference between the previous and current execution? There is a slight difference. And also I wanted to share with you an interesting video about the art of cognitive blind spots, which is from Kyle Ashen, and he's speaking about blind spots and why you can miss something important when you're working on something else. And I will share it in the notebook so you can have a look on it a bit later. And this is how you can make a big program smaller, and you can reuse some parts of the code. So let's move on some exercise. You can see that in this chapter you have several exercises, and even we're going to use the first one and do it in the next example for the subchapter encapsulation. So let's move on encapsulation. So what is encapsulation? This is when you wrap a piece of code in a function and you can call it later. Why you want to do this? Because you can reuse your code several times and your programs will be shorter, because it's easier to call a function twice than copy all the lines several times. So here you can see a sample solution for the first exercise from above. We are defining a function square. We pass a single parameter t, and then we are adding the code from the above, and we can reuse it later by calling the name of this function square and passing a parameter. You can see that we have again a bit difference. Here we are calling t forward, and above we are calling Bob forward. And the difference is because we want this to be working for a generic case and all general cases, and we don't want to pass Bob here and just work only with this variable. And you need to think for this in most of the cases that your code should be generic and do multiple things and not work only with hard-coded variables. Also, you can notice that we have some indents here, which is defining the statement, and we are saying with this that these two statements are part from the for loop. If you change the indentation order, for example, if we do this, we are going to get a different result, as you can see right now, because we are drawing 4 times forward and only 1 turn. That's why the pen is showing up. And if you return the statement as in the past, you can see that we are drawing a square, and this time the pen is showing to the right, and in the previous program you can see that it was pointing to the bottom. And this is because of in the loop we are calling 2 times forward and turn, and in the loop here we are skipping it, the last turn, but this is just a slight difference. So let's move on the next point, which is about drawing polygons and not only squares. And we can write a function with several parameters. You can see them here. We have 3 parameters, and we can do some calculations inside in order to calculate the angle. As you know, the circle has 360 degrees, and with division on n we can get the angle for a polygon. Then we can execute the function with this statement here. For example, we can write a polygon with 7 angles, and the length of the side could be 70. And let's check the example. You can see it here. You can do something similar, for example, to check for 10, for example for 10, you can do the same for 21 and so on, just to see how it is working. And here we can say two things, for example, that there are keyword arguments which can be used when you call a function, and this is going to help you to remember what is the parameter and what is the usage of it. So this is something like best practice in programming. It's just a recommendation, but I think that you're going to benefit from it. And now let's move on something else, which is about interface design. You can find the description that interface of a function is a summary of how it is used. And why this is important? Because you need to answer of several questions. What are the parameters? What does the function do? And what is the return value? And also that interface is clean, if it allows the color to do what you want without some unnecessary details or some small things which you don't need for your work. And now let's deep in this interface design and how you can use it. So the next step is going to be draw a circle by a given radius, which is going to be used as a parameter. So let's do it. So for this purpose we are going to use model math, which we saw in the previous videos. Then we're going to get a number of p or pi. We're going to calculate the circumference, and finally we're going to use function polygon, as you can see, which can be reused for this purpose with some approximation, and finally draw a circle. Let's check what is going to be the result. We can see that we have a circle here. We can change the radius by providing these parameters here, and let's rerun it. You can see again we have a circle. And now let's say that we want to do some improvement on this program. Can you see what is the difference? Right now we have a hard-coded value, which is not a good idea in programming, and it's better you to calculate this value. This could be a problem. For example, if you have a small circle, you're going to have a smaller execution because it's not optimized. And you can calculate n by using this formula here, and this is going to give you a better results and a faster execution. And this is how you need to think for your programs in future, that you can use some values in order to avoid hard coding of your programs and providing values which can work only in a given use case and not in all of them. And now let's move of refactoring, which is another important topic in programming. Most probably you noticed that we have similar code in function arc and polygon, and we can refactor it in a polyline, a new function. And this is how refactoring is working. You're rearranging your program in order to improve the interface and facilitate code reuse. So this is a program arc, which is similar to the circle, but in this function we're drawing arc and not a full circle. You can see the result here. And now how we can reuse it. We can define all functions, for example arc, to use polyline. You can see the definition for polyline here. And also I want to mention that first let's execute this and check the output. You can see the all functions here, and I want to mention that if you have separate functions for your program, you can debug them and find problems easier. For example, let's remove this line from function polyline. Then all you can do, run, and find that your program is not working as it's expected. And then you can start searching in the functions one by one and find, is this function doing what is expected or not. And you can think for a black box. You have input and output, and you need to check, is the input matching the output. And also you can debug and find problems in this way very easily. How to find which parts of your code are good for refactoring. You can search for repetitive pieces of code. For example, we can see these lines here, which can be found here, and we can find them even at the beginning. For example, we can see them here, and these lines are perfect for refactoring. And this is the process of refactoring, when you rewrite your programs and do them smaller, easier to be read, and working in a more generic way. So I put all the functions here, and you can find them, and how now the program is a bit more clear and easier to be used. For example, you can write a polygon, you can write draw arc and circle, and you can see how to use them. In order to do a good working plan, you can find some steps here. You can read it. It's a simple and generic one. You can do some improvements on it, but I will recommend for you to have something similar when you're doing and dealing with software problems. And now let's move on another topic, which is about docstrings. And what is a docstring? This is a docstring, which is something like a string at the beginning of a function, which is explaining what is doing this function, interface, method, class, and so on. It's shorter from documentation, and let's demonstrate how this is working and you can use it. You can find that we have two functions here. The first one is polyline, and the second one is square. You can see that we have a docstring here, which is written with triple quotes, and this one don't have it. If you try to find the documentation for the given function, you can do it in Jupyter Notebook by using Shift and Tab. You can find that we have some docstring, and the docstring is showing this information, which is really useful when you are new to this function and you want to get some information, how it is working, what it's doing, and so on. And you can find that here we don't have this information, and this is not good for the people who want to work and interact with your program. So I will advise you to add docstrings when it's possible, and for functions which are complex and need some extra lines to get idea what is going on. And finally, again about debugging, you have preconditions and postconditions, the input and the output, and you want to be sure that they match each other in order to be sure that this function is behaving as expected. And that's all for this chapter. You can find at the end some exercises which are really interesting one, and you can test it for yourself. Also, you can find a small glossary and read it about it. If you like this video and book, you can buy it from the author. You can find it the link on the official site on Green Tea Press. If you like the video, you can put a like and expect next video about the next chapter in a week or two. And the next chapter is about conditional and recursion, and it's interesting one, and we're going to start real programming, let's say. And also, if you have ideas for future books or something else, please free to write in the comment section below. Thank you for watching and see you next time.